So if you've ever seen video footage of the landing of the moon, when the astronauts were struggling to get the American flag erect, you'll notice that the flag was seemingly fluttering as if it were in the wind.
How is the quality of the TV?
Oh, it's beautiful, Mike. It really is.
Oh, geez, that's great. Is the lighting halfway decent?
Yes, indeed. They've got the flag up now, and you can see the stars and stripes on them.
Now, conspiracy theorists have used this as an argument to say that's why the moon landing was faked, because how could the flag flutter if there were no wind? And I'm going to wiggle the vacuum chamber in air, and then I'll suck the air out and wiggle the vacuum chamber again and see if we see the same flutter of the flag. Okay, 3, 2, 1. There we go. We're at 0.75 atmospheres. We're at a half an atmosphere now. We're at 0.3 atmospheres. This is about the atmosphere on top of Mount Everest. Okay, we're now at a pretty good vacuum in there. So now let's wiggle it and see if the flag still flutters. Here we go. Yep. Okay, so we have a full vacuum here, and you can see that the flag just waves still. Now this gold leaf is really thin, and the reason I chose this was to replicate about the actual thickness of the flag compared to the pull of the flag. And what I've also done is I did what they did to the real American flag, is they have a pull on the side, but they also have a pull going across the top. And that's to keep the flag laid out so that you can see the whole flag, and so it didn't just lay limp by the pull of the flag. Okay, let's let the air back in and see what happens to our flag. Okay, 3, 2, 1. Well, there goes our flag. So as soon as the air came in, all of that air just burst through and it ripped the flag to pieces. Okay, so why was my flag still able to wave around even though there was no air? Well, the reason has to do with something called inertia. And what inertia means is that it has a tendency to remain unchanged. So everything wants to remain unchanged. Nothing's going to move unless we move it. So when I move my fingers, the bottom lags behind because it takes time to feel the force of my finger through the sheet until it finally reaches the end, and then it can move. Now when you're in air, what happens is it also amplifies that effect. The sheet wants to remain even more unchanged because there's air around it creating drag. So in air, there should be even more of a lag than in a vacuum. Now in this experiment here, you couldn't really see that big of a difference between having air in it or not. And so when the astronauts were putting the flag on the moon, they were shaking the pull, and the pull was just causing the flag to shake. So there's no reason to think that something can't shake in space. It doesn't matter whether there's air or not, because things have inertia whether or not they're in a vacuum. Now the effect is stronger in air, that is true, because the air causes drag on the material. But the effect still shows up no matter what. So when you shake something like a big sheet like this, it will still flutter whether or not it's in a vacuum or in air. And thanks for watching, and I'll see you next time.